Hi everyone. So today we are going to discuss this important question given in GATE, I think 2021 or somewhere. So if you read, it has lengthy descriptions, but here what we need to find out is what is this configuration. So this is simply a common source configuration with PMOS input as well as PMOS load. Okay, this, so the simple solution of this is one. If you just see this, it has one. In 1 second you can give the answer. For common source, we have gain is equal to minus of gm into r out. So here r out, what will be the r out? Directly if you consider, gm will be the gm of this m2 and r out is r out at this point, which is r1 of this parallel with 1 by gm of this, because this is, we are seeing from the source of the MOS as well as this is diode connected. So r out will be simply ro, because ro are given, ro of 1 parallel with 1 by gm of 1 parallel with 1 by ro of 2. From here, if we'll see from here, it will be ro2 and this is r1 and the source terminal will give 1 by gm. That's why we can directly say the gain will be gm2 r1 parallel with 1 by gm1 parallel with r2. This is simply, whenever we are seeing from the source of a MOS, then it will have 1 by gm as a r, and because we have given r1 r2, so that will be in parallel. So this is simply from without using the small signal analysis. Now if you want, you can recheck using small signal analysis. Why make the small signal analysis here? This is your ro2, this will be grounded, because for AC analysis your VDD DC source will be grounded. So VDD DC source, here Vin is connected at your V gate, here is a V gate, this is drain terminal and the output terminal of the M2, this is source terminal and this is gate. So this current will be Gm into VSG. In case of NMOS, use VGS. In case of PMOS, use VSG. This is the difference. Okay, and for the lower MOS as well, we have this Gm. This is 2. This is 1. 2 VSG, and this is grounded, and RO1. Now, and gate of this second MOS Gm1 is grounded. So if from here, how you can calculate? Just current from here is equal to this current in second path, current from top. So current from top is Gm2 into VSG plus Vs minus Vo upon RO2 equal to Gm1 VSG plus VO, this terminal O, this is ground, VO upon R1. For a small signal, this will also be 0. You can see here, this is grounded. So, and this is also grounded. Here, for the second MOS, we have G is grounded. So, we will put Gm2 into 0 minus Vg. Vg is Vin. For Gm2, Vg is Vin here. So, Vg is equal to, we can put directly V of in plus Vs is 0 here minus Vo upon Ro2 is equal to GM1 into Vs. Here in this case, for this MOS, this one, Vs is VO. So VO and V gate is 0 minus 0 plus VO upon R1. Now you have V in and VO equation. So we can write VO to 1 into 1 upon 1 by GM1. We are making it this one 1 upon 1 by GM1 to just make them all similar. VO upon R02 plus VO upon R1 is equal to minus of GM2 into V. So, okay, we can make this is also VO. So from here VO upon Vin is equal to minus GM2 upon 1 by GM1, okay, not upon GM2 into 1 by GM1, VO upon Vin, yeah, 1 by GM1 plus 1 by R1, sorry, plus R2. So this will be obviously minus GM2, 1 by GM1 parallel with R1 parallel with R2. If you want, you can simplify, otherwise this is the answer. So you can see from small signal analysis, we need to draw first a small signal, then we have to calculate all these things. But in this case, we can directly calculate without using any small signal. Just we need to understand what is the configuration, and for common source we have GM, total GM of the circuit into R out of the circuit, that is the gain minus 1, and for common gate we have without minus, that is GM into R out. So we have to calculate GM of the network of the circuit, we have to calculate the R out of the circuit only. So the answer will remain same. Thank you.